So we will discuss the first step, which is common for both aerobic as well as anaerobic respiration, that is glycolysis. As I have said earlier, it is a splitting of sugar molecule. So if the respiratory substrate is glucose, then from one glucose molecule we finally have two molecules of pyruvic acid form, which is itself a 3-carbon compound. So how this happens? In following steps we will discuss oxidation of glucose, that is a partial oxidation or incomplete oxidation, into another organic compound. Glucose is itself an organic compound. A 6-carbon organic compound is changed into a 3-carbon organic compound. That is simply the splitting of sugar molecule. So I have will draw that is the respiratory substrate is the glucose, which is a 6-carbon compound. Glycolysis is a several steps, that is basically 10 steps that involve 11 compounds formed during glycolysis. So first of all, glucose, that is a 6-carbon compound, is converted into glucose 6-phosphate. Why glucose 6-phosphate is formed? Because phosphorylation, dephosphorylation is the most common type of reaction occurring in our system. So if phosphate is added to the end, then compound will be weak. So splitting will be easier. So first of all, in a cell, if phosphate is added to glucose, so in first reaction, glucose is converted into glucose 6-phosphate. That is also a 6-carbon compound. And for that glucose 6-phosphate, I have just completed all the reaction. Glucose 6-phosphate will change into fructose 6-phosphate. It will change into fructose 1,6-diphosphate. And then this fructose molecule is split into two molecule of 3-phosphoglyceraldehyde and dihydroxyacetone 3-phosphate. And this is also 6-carbon. This is itself 6-carbon. So it's glyceraldehyde, which is the simplest sugar, is a triose sugar. So it is also a 3-carbon compound. This is also a triose sugar, but exists in ketonic form, dihydroxyacetone. Third carbon phosphate is added. So it is dihydroxyacetone 3-phosphate. These two are isomers, so they can be interchangeable. So from 3-phosphoglyceraldehyde, we have 1,3-diphosphoglyceraldehyde. It's an unstable compound, will finally change into 1,3-diphosphoglyceric acid. It will change into 3-phosphoglyceric acid. Next, 2-phosphoglyceric acid. Phosphoenol pyruvic acid. And finally, that is pyruvic acid. So it's complete glycolysis as far as substrate and products are concerned. From here onward, 3-carbon compound, and pyruvic is also a 3-carbon compound. So all the compounds are of 3-carbon. So we have 3-carbon in this sense. We can also balance the carbon atoms. So these all are 3-carbon compound. If we consider that this 3-carbon compound, which is an isomer of this, because in aldehyde reactions are more common, So if this compound is converted into this, so we can also written as from 1,3-diphosphoglyceraldehyde onwards, we have 2 molecules of each compound. So here is 2 molecules of each. During the consideration that this dihydroxyacetone phosphate will isomerize into 3-phosphoglyceraldehyde. So from 1 glucose molecule we have 2 phosphoglyceraldehyde as we have considered during glycolysis, and so from this compound onward we have written 2 molecules of each. As far as during the reaction which occurs and the enzyme used, because glycolysis or the splitting of sugar is an enzymatic process. So as far as enzymes are concerned, and some enzymes require activator also. So from glucose to pyruvic acid, there are several steps occurring during glycolysis. So what basically happens during glycolysis is, first of all, glucose is phosphorylated and the product will be glucose 6-phosphate. Why we add phosphate group at the 6th position? Because if phosphates are added towards the opposite end, then compound will weak and split into 2, as during this reaction it will happen. So glucose is converted into glucose 6-phosphate. The enzyme used, because that phosphate, from where that phosphate comes, so always the easiest source of phosphate is the ATP, and if phosphate is released, then the easiest acceptor of this inorganic phosphate will be ATP. So ATP-ADP interconversion is the most preferred reaction during biochemistry in the cell. So this phosphate comes from the ATP molecule. So we have also written this ATP, and there will be formation of ADP. So 1 phosphate from ATP is added to glucose and the compound will be glucose 6-phosphate. Because this phosphate comes from the ATP that is used as substrate, and these are the products. If we simplify the reaction, we will written as glucose plus ATP equals to glucose 6-phosphate plus ADP. So in general, this is glucose plus ATP equals to glucose 6-phosphate plus ADP, because that phosphate comes from the substrate. This step will be the substrate level phosphorylation. So first of all, 1 molecule of ATP is used in substrate level phosphorylation for the formation of glucose 6-phosphate from glucose. Compound will be of 6 carbon, same. Glucose is converted into glucose 6-phosphate. The enzyme used in this step is the hexokinase. And it's an allosteric enzyme. If you study enzymes, then we have allosteric enzyme. And for this enzyme, magnesium ion is used as an activator. So most of the enzymes of glucose, most of the enzymes in glycolysis, we have magnesium ion as an activator. So in presence of enzyme hexokinase, 1 ATP molecule is used and product will be glucose 6-phosphate. Now glucose 6-phosphate is converted into fructose 6-phosphate, because glucose and fructose are isomers. So enzyme will be in general isomerase, or we can say hexoisomerase, because hexose, that is a 6 carbon sugar, and glucose is converted into fructose. Glucose is a 6 carbon aldose and fructose is a 6 carbon ketose sugar. So enzyme here will be hexoisomerase. And again magnesium ion is used as an activator. So simple reaction is a isomerization. If we also written the step, then here is substrate level phosphorylation. And in the second step is the isomerization. Of 6 carbon sugar, so glucose is converted into fructose. Clear? So in the next step, fructose 6-phosphate, we have fructose 1,6-diphosphate, then 1 extra phosphate is here, so that extra phosphate also comes from the ATP. So there is another ATP molecule is used, and we have formation of ADP. So because ATP molecule is used, so again that is another a step of substrate level phosphorylation. And the enzyme is the fructose 1,6-diphosphate is the product, fructose 6-phosphate is the substrate, ATP is the substrate, ADP is the product. So 1-phosphate comes from the ATP, so the step will be substrate level phosphorylation. An enzyme will be fructose 1,6-phosphate or fructose. It is phospho because phosphate is added, fructose, fructo, ATP is used, so enzyme as per category will be kinase, and for that also we have magnesium ion as an activator. So enzyme will be phosphofructokinase. Phosphate hai, fructose hua, fructose kinase because ATP is used. So step will be the substrate level phosphorylation, but because here ATP is used, initially we use ATP and so that this glucose will split finally into pyruvic acid. Now fructose 1,6-diphosphate has 2 phosphate compound at the opposite end. One is the first carbon, another phosphate is the 6th carbon. So now this compound is unstable. It is broken down into the 2 compound, that is phosphoglyceraldehyde and dihydroxyacetone phosphate. These are also isomers, so they also can be changeable. The enzyme involved as that step is the aldolase. So aldolase is the enzyme and the step is that is simply splitting of hexose sugar. So hexose, that is the fructose. Sugar is split into 3 carbon compound, that is phosphoglyceraldehyde and dihydroxyacetone phosphate. 2 phosphate in this compound, one with the phosphoglyceraldehyde, one with the dihydroxyacetone phosphate. These 2 are the isomers, so the enzyme will be simply isomerase. And here also magnesium ion is used as an activator. Now this 3-phosphoglyceraldehyde is converted into 1,3-diphosphoglyceraldehyde, and here that phosphate comes from the H3PO4, that is phosphoric acid. And this is the only step which doesn't involve any enzyme. It's a non-enzymatic step. So that reaction is the integration of inorganic phosphate. So inorganic phosphate is integrated in the form of H3PO4 and the product will be 1,3-diphosphoglyceraldehyde. Now this 1,3-diphosphoglyceraldehyde, here is no any enzyme because this step is non-enzymatic. So 1,3-diphosphoglyceraldehyde is changed into 1,3-diphosphoglycic acid because aldehyde is changed into glycic acid. As per organic chemistry, it is simply an oxidation step. So here diphosphoglyceraldehyde is changed into 1,3-diphosphoglycic acid. The energy is in the form of NADH2. So from NAD, we have formation of NADH2. So one molecule of NADH2 is formed here. So 1,3-diphosphoglycic acid is converted into 1,3-glyceraldehyde is converted into 1,3-diphosphoglycerate or simply glycic acid. Enzyme will be diphosphoglyceraldehyde, and as per reaction, it is a dehydrogenation reaction. Hydrogen is removed from this. It is accepted by the NAD, so the product will be NADH2. So enzyme will be dehydrogenase. So it is simply diphosphoglyceraldehyde dehydrogenase, because the dehydrogenation reaction occurs here. And again, the activator will be the Mg2 positive. So diphosphoglyceraldehyde dehydrogenase enzyme is used and 1,3-diphosphoglyceraldehyde is converted into 1,3-diphosphoglycic acid, and in this step one NADH2 molecule is formed. So from 1,3-diphosphoglyceric acid, now we have 3-phosphoglycic acid. Here one phosphorus is removed. So that phosphorus is picked up by the ADP molecule convert into ATP. So this is also have one ADP molecule that accept the 1-phosphate removed from the 1,3-diphosphoglysicaldehyde, and so that one molecule of ATP is formed. So if ATP is formed here, so 1-phosphate is in ATP and 1-phosphate remains as such, the product will be 3-phosphoglyceric acid. Because here 1-phosphate is picked up by the ADP and ATP will form, this reaction is also the substrate level phosphorylation. And again the enzyme will be diphosphoglycerate kinase. Activator will be same, Mg2 positive. Now we have 3-phosphoglyceric acid. Then this 3-phosphoglyceric acid is converted into 2-phosphoglyceric acid. There is change in the position of phosphate group. That is, in this molecule at the 3rd carbon, in this molecule at the 2nd carbon. So if the position of phosphate group is changed in the same molecule, then the enzyme will be phosphoglycerodismutase. Mgn as an activator, same. These are the basically positional isomers. So the reaction will be simply the isomerization. So this, now 2-phosphoglyceric acid is changed into 2-phosphoenol pyruvic acid. So from this step, one water molecule is released. The enzyme will be enolase, which has manganese as an activator. So this is removal of water molecule, so it will be the dehydration step. And now finally from 2-phosphoenol pyruvic acid we have one molecule of pyruvic acid, 2 to 2, 1 to 1. So this second position phosphate is removed, that is picked by again ADP, and that ATP will be formed. So in the last step we also have ADP molecule used to form ATP molecule, because ATP is formed, that is again the substrate level phosphorylation.